Okay, first worksheet, confidence interval for proportions. The success criteria would be you should be able to construct and interpret a confidence interval for a population proportion. And then we are given the formula right here. You got the percent confidence interval is equal to the your estimate. Let me change pen. Okay. So this is your sample proportion plus minus the critical z times the square root of PQ over N, which is, we call it our standard error. This one right here. Okay, so all of this expression right here, the Z crit times the SE, is actually what we call our margin of error. Okay, and we have right here the common critical Z values, or we call it Z crit. So if the percent confidence is 90%, the Z crit would be 1.645. If it's 95%, 95% is the most common. And so the Z crit for that is 1.960. And for 99%, it's 2.576. Okay. You can pause the video here so you can read the problem. Okay, first thing I'm going to do is to highlight the important givens. First, we have the 190 pieces of seafood right here, and this is our sample size, which is the N. So our N would be 190. Okay, and then we have the 22% right here, and that would be our sample proportion, which is P hat. P hat would be 0.22. Okay, and so our Q hat would be 1 minus 0.22, or that would be 0.78. Okay, and then we are being asked to produce a 95% confidence interval, and so we go right here. This would be the critical C we're going to use. So the Z crit that we are going to use here would be equal to 1.960. Okay. The first step of doing a confidence interval would be to state the assumptions and conditions. So I'm going to write assumptions and conditions. You have to remember that all the formulas given above came from the Bernoulli trials. And so if you can recall, there are three conditions for the Bernoulli trials. They have randomness, independence, and what was the third one? 10%. The 10% is for the constant probability. Okay, and then if the fourth condition would be, if you remember, before we can use the normal model, we have to have the success failure condition, meaning we have to have at least 10 successes and 10 failures. Okay, so I'm going to write the conditions now in context. Okay, so I would say the 190 pieces of seafood were randomly purchased or randomly sampled. Then number 2, independence. Each pieces of oops, each pieces of seafood is independent. Okay. From each other. Okay, and number 3, the 190 pieces of seafood is less than 10% of all seafood. Okay, and then lastly, our success failure condition. So I'm going to write success / failure condition, and you should remember this. How do we get the number of success? It's going to be n times p, and that should be greater than or equal to 10. And then okay, so let's substitute values here. N is 190 times 0.22. Is that greater than 10? So okay, let's see. We calculate. Oops. We go. Okay, calculate. Let's go down. Okay, right here. That would be 190 times 0.22 is going to give us 41.8. Okay. So 41.8 is greater than 10. So we have success right here. We got 10 successes, more than 10 successes. And then let's compute the number of failures. So NQ should be equal to or greater than 10, and we substitute values again. We got 190 times 0.78, and that should give us, compute again, we got 190 times 0.78 is going to give us 148.2. okay, so 148.2. okay, so we have failure, we have at least 10 failures. Okay, and so we proceed with the computation of the confidence interval now, and we are going to use this formula right here, okay, so let me just rewrite the formula. It's going to be 95% confidence interval, or CI, is going to be the p hat, the sample proportion, plus minus the margin of error. And the margin of error is given by the critical Z times the standard error, which is p hat q hat divided by n. Okay, and then we substitute values. Our p hat is 0.22 plus minus, remember our z crit is 1.96, so 1.96 times the square root of 0.22, okay, times 0.78 divided by n, and the n is 190. Okay, and that should give us 0.22 plus minus. Okay, if you're going to do that using your calculator, you are going to get 0.0589. Okay, and so if you are going to do 0.22 minus 0.0589, we are going to get 0.161 or 16%. And then if we are going to add, that would be 279, I think. So that would be 28%. So the 95% confidence interval is from 0.161 to 0.279. Okay. And then we state our interpretation of the confidence interval. And this is something standard, okay? We are going to say we are 95% confident that the true proportion of seafoods that were mislabeled or what is that? Misidentified is from, you could say that's 16% to 28%. So okay, there you go. Booyah, finish, done.